At this point, you should be skilled at assigning oxidation numbers to various chemical molecules. Oxidation numbers can help us determine which species are being oxidized and which species are being reduced, as in which species are gaining electrons and which species are losing electrons. Before we start talking about reactions and oxidation and reduction, I'd like to give you a mnemonic device to help you remember what is oxidation and what is reduction. The mnemonic device is Leo the lion says grr. Leo stands for lose electron oxidation. grr stands for gain electron reduction. Knowing this little saying will help you remember what is oxidation and what is reduction. So let's fill this out together. When an element is oxidized in oxidation, its oxidation number goes up. So for instance, its oxidation number could go from +2 to +3. That is defined as the loss of electrons. Remember, when something becomes more positive, it is losing electrons. When an element is reduced, its oxidation number goes down. For instance, if it were to go from +2 to 0. Anytime where the positive number decreases, it's gaining electrons because it's gaining negative charge, thus making this go down. Reduction is defined as the gain of electrons. In redox reactions, redox is a portmanteau between reduction and oxidation. So oxidation reduction reactions are often called redox reactions. It's two words smushed together. It's impossible to have oxidation without reduction. That is because if one species is to gain electrons, they must gain electrons from another chemical species. They cannot just gain electrons from nowhere, and vice versa. If there is a loss of electrons, the electrons have to go somewhere. There is no intermediate. There is no electrons on their own. All right, let's do some examples where we use our oxidation numbers to answer the following questions. First question asks, if NO3, this is nitrate, is converted to N2, has the nitrogen been oxidized or reduced? What you need to do here is determine the oxidation numbers of the nitrogens in order to determine if it's been reduced or oxidized. So let's assign our oxidation numbers here. Oxygen is always -2. The overall charge is -1. Thus, nitrogen has an oxidation number of +5. -2 plus -2 plus -2 plus +5 gets us -1. And based on our pink page, a substance that is in its elemental form, N2 is a diatomic, so this is its elemental form, the oxidation numbers are 0. In this case, the nitrogen is going from +5 to 0. Take a guess now as to whether that's oxidation or reduction. If you said reduction, you would be correct. Nitrogen is reduced. It's gaining 5 electrons, going from +5 and gaining 5 electrons to become 0. Okay, let's do the second one. If H2CO3, that's carbonic acid, is converted to CO2, has the carbon been oxidized or reduced? So we need to do the oxidation numbers again. Let me show you how that comes out. Hydrogens are always +1. Oxygens are always -2. The overall substance is neutral. So if we add up what we have already, +1 plus 1 is +2, plus -6 is +4. Thus, our carbon must be +4. And then we do CO2, -2, -2. CO2 is also a neutral molecule, so carbon must be +4. The carbon in this situation is neither reduced nor oxidized. Neither for this one. +4 to +4, there is no change in oxidation number. Let's do C. If hydrochloric acid is converted to Cl2, has the chlorine been oxidized or reduced? We again assign our oxidation numbers. Chlorine, like this, Cl2, is in its elemental form, and any atom in its elemental form has an oxidation number of 0. Don't worry about the balancing. So here our chlorine is going from -1 to 0. This is an increase in the oxidation number. It's losing 1 electron to become 0. The chlorine is oxidized. Let's do the last problem here. Using oxidation numbers, determine why the reaction below is impossible. First, we need to assign the oxidation numbers. I'll start with this perchloric acid, HClO4, +1, -2 for all of our oxygens. This is a neutral substance, so if we add it all up, chlorine has a +7 oxidation number. Our hydrogen is an ion. It has a +1 oxidation number. And then we do our oxidation numbers here. +1, -1, and each hydrogen is a +1, and there's 2 of them. So I'll write it like that. And our oxygen is -2. That's a neutral molecule. So we look at just the chlorine, because that is the only oxidation number that is changing. Chlorine goes from +7 to -1. It is reduced, gaining 8 electrons. However, this reaction is impossible because there is nothing supplying the electrons. If you look at the reactants, chlorine would have to gain electrons from the other reactant, which would be hydrogen ion, H+. But you'll notice here that the oxidation number of hydrogen stays the same. There is no change in electrons for our hydrogen atom. Therefore, this is impossible because there's no oxidation happening. And without oxidation happening to another chemical species, another molecule, there's nowhere for chlorine to gain electrons from. So this is an impossible reaction. All right, so for the second page, you're on your own. What you need to do for each of the reactions is assign the oxidation numbers, so to every atom, on both sides of the chemical equation. And then you need to write which atom is being reduced and which is being oxidized by identifying the change in oxidation number. So the first one has been done for you. The oxidation number of iron to start is +2. The oxidation number of aluminum solid, which is in its elemental form, neutral, 0. Aluminum 3+ gets a 3+ oxidation number, and iron solid is 0. We're not going to worry about balancing at this point. So then you write it like this for each of your reactions. Iron goes from +2 to 0, and it is being reduced. And aluminum goes from 0 to +3, aluminum is oxidized. So that's what I want you to write for each of the reactions after you do the oxidation numbers. So there are 4 for you to do. And number 4, you need to draw your own pictures. See if you can do that. You might need to look it up, and that's okay.